In section 6.3, we look at the hyperbola. Let's start with the definition. A hyperbola is the set of all points in a plane such that the absolute value of the difference of the distances of those points from two fixed points is equal to a fixed positive number. The two fixed points of the hyperbola are called the foci, or individually, they are called the focus. Each one is called the focus. And this is very similar to the definition of an ellipse, except that now it is the difference of the distances instead of the sum of the distances. So if you look at the picture we have here, you can see the hyperbola has this kind of a shape, which probably reminds you a little bit of a parabola. Please understand that this shape is not the same as a parabola, but it does have, some similar characteristics. Anyway, if you look at the point on the hyperbola here, there is a fixed point over here, which is one of the foci, and there is a fixed point over here, which is the other focus. If you take the longer distance minus the shorter distance, that number is always a constant when you are a point on a hyperbola. So that's the definition. What we want to do is recognize what the equation looks like when we have a hyperbola, and we want to be able to find all the important things like the center, the vertices, and the foci. So let's go ahead and take a look at the equation. So if you have a hyperbola with a center at the origin, the equation, if we jump down here, you'll notice looks very similar to an ellipse. The only difference is instead of having a plus sign right here, you have a minus sign. So the equation is either x squared over a squared minus y squared over b squared equals 1, or it is y squared over a squared minus x squared over b squared equals 1. And in this case, a and b are both positive numbers, and it doesn't matter which one of these is larger. So remember, for an ellipse, a had to be larger than b. For a hyperbola, that doesn't have to be true. So the number a is always under the first variable. And when your first variable in the equation is x, it is what you might call a horizontal parabola, horizontal hyperbola. So you'll notice that both hyperbolas open side to side. And when the y variable is first, you'll notice that they open up and down. Now, if we zoom in just a little bit here, I want to point out some important aspects of a hyperbola. And that is that they have these lines called asymptotes. And these asymptotes, you can see them here. They are these diagonal lines, two of them. And the idea is that as this hyperbola moves outward, it gets closer and closer and closer to that line. It never actually touches the line. I know it appears to touch, but it doesn't actually touch. It just gets closer and closer and closer to those lines. So one of the things you have to graph when you're graphing a hyperbola is you have to graph these asymptotes. And I'm going to show you a very easy way to do that. Now you'll notice here they give you all the information. So they tell you where the center is, 0, 0. They tell you the foci are at the points negative c0 and positive c0. And they also tell you how to find c. I want you to remember that when you're looking for c in an ellipse, there was a minus sign here. And in a hyperbola, there is a plus sign here. So a very similar formula, but a little bit different. The vertices are also at negative a0 and positive a0. And then you have this thing called the transverse axis. The transverse axis is basically the axis that goes between the two vertices. So, for example, it is this little segment right here. And then they give you the equations of the asymptotes, but the good news is you don't have to really remember any of this stuff. All you have to know is the basic equation, and you have to remember how to find c. And once you know those things, there's a really simple, easy way to graph hyperbolas. So let's take a look at an example. So in our first example, we want to graph the hyperbola given by this equation here, and we want to write the equation in standard form, determine the orientation of the transverse axis. So in other words, is it horizontal or vertical? Find the coordinates of the vertices and the foci, find the equations of the asymptotes, and then sketch the hyperbola and indicate the vertices, foci, and asymptotes. Okay, so a lot to do here. First thing I want to do is just take the equation 16x squared minus 9y squared equals 144. And we need to put that in standard form, which means it needs to be equal to 1 on the right-hand side. So what I'm going to do here is divide by 144 on both sides of the equation. So every term gets divided by 144. And then we need to know that 16 goes into 144 9 times. 9 goes into 144 16 times. And of course, 144 divided by 144 is 1. So the simplified version is x squared over 9, which we can think of as 3 squared. Then we have minus y squared over 16, which is 4 squared, and then equals 1. So here is the equation in standard form. So we did that first part there. Now it says determine the orientation of the transverse axis. The orientation is that it is horizontal. And the reason it's horizontal is because your horizontal variable, right, x, appears first. And that's how we know that it's horizontal. So if this had been a y and if this had been an x, then we would say the orientation is vertical. But in this case, it's horizontal. All right, so we've answered part A. Next, it says to find the coordinates of the vertices and the foci. Okay, so here's the part where you need to pay attention. So first, let's just recognize that the center of this hyperbola is at the point 0, 0. Now, what we do from there is we look at the number underneath the x variable, which remember that number was a 9, but 9 is 3 squared. And it's that number 3 that matters. And what that means is from the center, we are going to put a point 3 units to the right and also 3 units to the left. The exact same way you would do if you were graphing an ellipse. And then under the y variable, we had 16 here, which is 4 squared. So from the center, we are going to go 4 units up and 4 units down. And of course, if you were doing an ellipse, you would just draw your oval and you would pretty much be done. But with a hyperbola, what we're going to do with these 4 points is we're going to draw a rectangular box. So it looks like this when we draw this box. And the really nice thing about drawing this box is once you have that box, you can easily draw the asymptotes. The asymptotes are the diagonal lines that go through the corners of the box. So one of our diagonals is going to go through this corner of the box, the center, and then the other corner of the box. And so that diagonal will look something like this. And we continue that in the other direction. And this should be a dotted line because it's not actually part of the graph. And then in the other direction, the other diagonal, we have another one like that. Okay, and that is our asymptote. All right. Now, because we know that this is a horizontal hyperbola, we know that it is going to open one to the left like this and one to the right like this. And the nice thing is these points right here on the edge of the box, right here and right here, those are the vertices. So let me go ahead and make a nice big blue point there. So one vertex is the point -3, 0. The other vertex is the point +3, 0. Okay. And then to get the foci, we need the value of C. Okay, so remember, we know that A is 3, B is 4, and c is equal to the square root of a squared plus b squared. So that's going to be the square root of 3 squared plus 4 squared. And if you do the math on this, you get the square root of 25, which is 5. So what that tells us is from the center of the hyperbola, we go 5 units to the right. We'll put a point there. And we go 5 units to the left, and we'll put a point there. And those 2 points are the foci. So we have focus 1 and focus 2. And now for the shape of the hyperbola, you don't have to find precise points to graph this. Basically, it comes out of the vertex and it moves closer and closer to this asymptote as it moves outward. So on this side of the graph, it looks kind of like this. And on the other side, it looks very similar like this. And so I have everything, I think. I found the coordinates of the vertices, yes, these 2 points. I found the coordinates of the foci, which are these 2 points. I sketched the hyperbola. I have indicated the vertices, the foci, and the asymptotes you can see right here. I guess the only thing I really didn't do is part C, where it says find the equations of the asymptotes. That's not that hard to do. Okay, when you have a line that goes through the origin like this, all you need to do is know the slope of that line to get the equation of the asymptote. And the slope is positive 4 over positive 3. And the slope of this line would be negative 4 over positive 3. So the equations of these asymptotes are y equals plus or minus 4/3 x. Okay, so now I think I have everything. That's part C. Let's go ahead and label that. And part D, I've sketched it. And I guess the only other thing you could do is write down the coordinates here. So this is 5, 0. This point right here is 3, 0. This point over here is negative 3, 0. And this point right here is negative 5, 0. All right, so now we have everything labeled appropriately. In our next example, we want to find the equation of a hyperbola. It says determine the equation in standard form of the hyperbola with center at the origin, one focus at the point 0, 4, and one vertex at the point 0, negative 1. Find the other focus and the other vertex. Sketch the graph of the hyperbola by finding and plotting some additional points that lie on the hyperbola. All right. So let's go ahead and label what we have. We have the center of the hyperbola is at the origin. We have one focus is at the point 0, 4, which I like to do with a red dot. One vertex is at the point 0, negative 1. Okay, so this is a vertex here. This is a focus here. And of course, this is the center. Now, the nice thing about hyperbolas is we have symmetry. So if this is the center, and if one vertex is 1 unit below the center, the other vertex has to be 1 unit above the center. So the other vertex would be here, and I'll call this V1 and V2. And then up above here, this is focus 1. Focus 1 is 4 units above the center, so the other focus will be 4 units below the center, again, because we have symmetry. Okay? Now, the other thing that we know is that this is a vertical hyperbola because your transverse axis, in other words, the line that has all the important points on it, is vertical. So if we have a vertical hyperbola, we know the equation is y squared over a squared minus x squared over b squared is equal to 1. We know that the distance between the center and the vertex, so this distance right here, this is equal to the value of a. So for this problem, we know that a equals 1. The distance between the focus and the center is the value of c, so we know that c equals 4. And the only question is, what would b be equal to? Well, let's remember that the equation that relates a, b, and c is c equals the square root of a squared plus b squared. So if we know that c is 4, And if we know that a is 1, we can use this to find the value of b. So all we have to do is square both sides. This will give us 16 is equal to 1 plus b squared. So what happens here is the square and the square root cancel. And if we subtract 1 from both sides, we get 15 is equal to b squared, which means b is equal to the square root of 15. All right. Now the square root of 15, if you plug that into a calculator, you get about 3.9. That's for graphing purposes, all right? But for the actual equation, b squared is actually the value that we need, right? So we're just going to put b squared, which is 15, right in there. And a is 1, which means a squared would also be 1. So the equation of that parabola actually becomes y squared over 1 minus x squared over 15 is equal to 1. And you actually don't have to write the 1 under the y squared. So you could just give the equation in this form right here. So that's the equation of it in standard form. We already did that. They do want us to sketch the hyperbola. So to do that, what we have to do is we have to take the square root of 15, which we know is 3.9. And from the center, we need to go 3.9 units to the right and to the left. So if I go 3.9 units to the right and 3.9 units to the left, then what I can do is I can make my box like so. And then I can draw the asymptotes, which look like this. And the other asymptote in the other direction looks like this. And finally, I can graph the hyperbola. I don't have to find actual other points out here. You could always do that by plugging numbers into your equation. But if I just sketch the graph here, because that's all we really want is a sketch, it's going to be a really wide looking hyperbola that opens up and down. Okay. Now, just to be fair, if you really did want to get additional points on the curve, you could just plug in a number for x or y here. So, for example, you could plug in x equals the square root of 15. So let's just do that real quick. If I plug in x equals the square root of 15, then y squared minus the square root of 15 squared over 15 will be equal to 1. And this will be y squared minus 1 equals 1, which means that y squared would be equal to 2. And so y would be plus or minus the square root of 2, which is approximately plus or minus 1.4. So when x equals the square root of 15, which is this value right here, the y value is approximately the square root of 2, which is 1.4. So that would give us that point there, and it would also give us this point here. So like always, if you want to find points on a curve, you can always plug in values of x or y to find points. But for the sake of graphing the hyperbola, just to capture the main features of it, you don't actually have to find precise points. You can just sketch the graph like this. And again, what you want to show here when you sketch it is that the hyperbola should be getting closer and closer to these asymptotes here as it moves outward. So then the only other thing to talk about here is what to do when the center of your hyperbola is not at the origin. And just like what happened with the ellipse, if the center is not at the origin, if it's at some point hk, then your equation just has an x minus h and a y minus k in it. So if you compare this equation to the equation previously, it's the exact same thing, except that now instead of having just x squared here, we have x minus h squared. And instead of having y squared here, we have y minus k squared. From there, you can get all of this information by just knowing the values of a, b, and c. And if you want to memorize all this stuff, you can, but it really isn't necessary for sketching the graph of a hyperbola. So let's go ahead and take a look at an example where the center is not at the origin. So in this next example, it says to determine the equation in standard form of the hyperbola with foci at 4, 3 and 4, -7, and a transverse axis of length 6. Find the asymptotes and sketch the hyperbola. So as I've said before, when you get information like this, it's really, really helpful to sketch a graph of what you're looking at, and then that's going to help you determine all the important information you need. So let's bring a graph in, and let's go ahead and sketch these important points. So we have a focus at the point 4, 3, which is right here, and another focus at the point 4, -7. 4, -7 is right there. And we'll call this focus 1, and we'll call this focus 2. It doesn't matter which one you call which, all right? And then we know that the center of this hyperbola has to be somewhere on the line between the foci, and it has to be right in the middle, right? So if this is 3 units this way and 7 units this way, that's a total of 10 units. So if I just go 5 units down from this focus or 5 units up from this focus, we can see that the center must be at this point right here, which has coordinates 4, -2. So the center is at 4, -2. And they also tell us that the length of the transverse axis is 6. So remember, the transverse axis is the segment that goes from the vertex to the vertex. So if the length of this transverse axis is 6, it means we have to go 3 units above the center and 3 units below the center. So one vertex would have to be right here. We'll call this V1. The other vertex would have to be down here. We'll call that V2. And now we can see that the value of A is 3 units, and the value of C is 5 units, and that will allow us to find the value of B because we know that C equals the square root of A squared plus B squared. And so if C is 5 and if A is 3, we can plug that in, square both sides, we get 25 equals 3 squared plus B squared. This means that B squared is 16, therefore B is equal to 4. All right, so now if I want to sketch the graph of this thing, we know that from the center we have to go 4 units to the right and 4 units to the left because that is the value of B. And then once you have those 4 points, you can sketch your box. And remember, the reason we sketch the box is because we want to be able to graph the asymptotes, which go through the corners of that box. Like this. Okay, so now, since we know that this is a vertex and this is a vertex, we know that the hyperbola basically opens up like this. And also it opens down like this. And that's the basic sketch. And you can see all the important information. So you could give the coordinates of the foci here just by looking at your graph. You could give the coordinates of your vertices, again, just by looking at the graph. You can give the coordinates of the center by looking at the graph. And you can also give the coordinates of the asymptotes. But actually, let's go ahead and give the equation of the hyperbola because they did ask for that. Now, this is a vertical hyperbola, right, opening up and down. So we know it's going to be y minus k squared over a squared minus x minus h squared over b squared is equal to 1. We know the coordinates of the center, again, are 4, -2. So this is the value of h, and this is the value of k. We already determined that a was 3 and b was 4. So all we have to do is plug all that in, and we get y minus -2 squared over a squared, which is 3 squared, minus, and then x minus h, which is 4 squared, over b squared, which is 4 squared, that has to be equal to 1. And so here is the equation of our hyperbola in standard form. Now, for the equations of the asymptotes, we talked earlier about how the equation is y equals plus or minus, and then you just have to find the slope of the line, right? So I'll call the slope of the line m and then x. So that's how you find it when it's going through the origin, but these lines don't go through the origin, they go through the center here. So in this case, the equations of your asymptotes are just going to be y minus k equals plus or minus the slope times x minus h. And that's just because both of your asymptotes also go through the center of the hyperbola. So in this case, the asymptotes are going to have equations y minus k, so it's y minus negative 2, which is y plus 2, equals plus or minus the slope. Now we know the slope from here to here is to go up 3 to the right 4, so that is 3/4, multiplied by x minus h, and that's x minus 4. And then, of course, it's plus or minus because you have one that has a positive slope and you have one that has a negative slope. But again, you can figure all this stuff out without memorizing a bunch of different formulas. You just need to know the basic equation of a hyperbola. You need to know the relationship between a, b, and c, which I had on here earlier. And then you need to know what those numbers mean in terms of the graph. So in our last example, it says we want to complete the square to write the equation of a hyperbola. They give us the equation in this form, and they want us to find the vertices, the foci, and sketch the hyperbola. So let's go ahead and start with the equation. And what I want to do first, since I know I have to complete the square, is let's put the x terms next to each other, and let's put the y terms next to each other. And if we do that, we get the following. And then the next step is, when you want to complete the square, you have to have a number 1 in front of your squared variable, which we do right here. So that's good news. But on the y squared, notice that we don't have a 1 here. So whatever number you have there, you have to factor that number out of both of these terms. So if we do that, we get the following. So you should notice that I have factored a negative 4 out of here, which leaves us with y squared. And when you pull negative 4 out of negative 24, you end up with positive 6 multiplied by y. Now we're ready to complete the square. So we need to add 1 here, and that comes from taking half of 2 and squaring it. And here we need to add 9. That comes from taking half of 6 and squaring it. Then you have to add the same numbers to the other side. So here you can see we just added 1. So to cancel that, we just need to add 1 over here. But right here, even though we added 9, actually there's a negative 4 multiplied by that 9. And negative 4 times 9 is negative 36. So I need to subtract 36 in order to do the same thing to both sides. That's probably the trickiest step. And we've done that before on a couple of other types of problems, so I hope you're starting to get used to it. Now let's go ahead and clean this up. We can factor this, and we can factor this, and we can add up those numbers, and that gives us the following. And now, to make this into standard form, what we need to do is have a 1 here, so we have to divide everything by 4. And when we do that, we get what you're looking at here, basically, except that these 4s will cancel, and these 4s will cancel, leaving you with a 1 right there. And let's go ahead and write that equation. All right, so there is the cleaned up version of that equation. And now from here, we should be able to get all the important information that we need to sketch the graph, find the vertices, the foci, etc. So let's start by recognizing that the center of this hyperbola will occur at -1, -3. Let's confirm that the value of a is the square root of this number. Remember, this number is a squared, so a would have to be 2. b would have to be 1, right? Because the square root of 1 is 1. And once we know a and b, we can find the value of c. c is the square root of a squared plus b squared. And that, for this problem, is the square root of 5. Now, let's go ahead and bring in a graph. And let's put down this important information. So the center is at -1, -3, which is right here. We know that this hyperbola is horizontal. And it's horizontal because the x variable appears first. So that means it opens side to side. So from this center, we need to go a units to the right and a units to the left, so 2 units each direction. And then from b equals 1, we know that from the center we go up 1 unit and down 1 unit. And then we can make our rectangle. And then once we have that rectangle, of course, we can draw the asymptotes, the diagonals. So just think of these as kind of like infinite diagonals. And we know this hyperbola opens to the left and to the right. So we're just going to kind of sketch the hyperbola. Remember, it's supposed to get close to these asymptotes, but not touch the asymptotes. And the last thing is we should put in the foci. The foci are radical 5 units away. And radical 5 is approximately 2.2. And so basically from the center, I'm going to go 2.2 units to the right. So that's a point that's right about here. And 2.2 units to the left. Now, when you have to give the coordinates for those in your homework, you need to be kind of careful, right? So the vertices are pretty simple. So if I call this vertex 1 and vertex 2, we can see that vertex 1 has coordinates -3, -3. And we can see vertex 2 has coordinates +1, -3. And then when you get to the foci, so here's focus 1 and here's focus 2. For focus 1, the x-coordinate is like -3 point something, right? But if you want to give that as a precise number, what you have to do is start at the center, which occurs at x equals -1, and you have to move c units to the left. So I know the distance between here and here is the square root of 5, and the distance between here and here is the square root of 5. So the x-coordinate of focus 1 is going to be, you start at -1 and you move the square root of 5 units to the left. So that's -1 minus square root of 5. And of course, the y-coordinate is -3. And then for focus 2, you start at -1 and you move square root of 5 units to the right, right? So we start here and we move in this direction to get to the focus. So to give those precise coordinates in your homework, you're going to have to enter it like this, right? You don't just enter that as a decimal. You should enter it as an exact value. Okay, so that pretty much concludes the section on hyperbolas.